Greetings, Chem 1 students. This is Mr. Braun, and today we are going to talk about uncertainty. Yeah, we all have some uncertainty in our lives. I'm uncertain what I'm going to be doing tonight after school. I'm sure my wife has some ideas for me, mowing the lawn or something like that, but we all have some uncertainty. Today we're going to talk about some uncertainty for a single measurement. Now, as I click on my smartboard with the technology here, we see that we have two different types of measurements here. The one on the left is a digital measurement. Real nice, real easy. That scale is going to tell you what the reading is. The one on the right, the analog scale, you have to actually make the reading. The scale does not tell it to you. So those are the two different types. Now, we have uncertainty in different ways with both types of these measurements. So, absolute uncertainty is an instrument's uncertainty or the readability error. We talked about this a little bit earlier, how one student might read something, say, as 52.5, whereas another student reads it as 52.6, yet another student reads it at 52.4. So there's a little bit of difference in our readability, so we have to have this uncertainty. Now, if we are dealing with an analog instrument, we take 1/2 of the smallest increment. Just remember that 1/2, because I'll show you how we're going to do that here in a second. But remember, we take 1/2 of the smallest increment. If we have a digital instrument, we look at the smallest scale division. Once again, we'll work an example of this here at the end. The smallest scale division. All right. Now, how we make this particular measurement is we have the reading, and then we put a plus or minus the absolute uncertainty. So the reading plus or minus the absolute uncertainty. Now I look right here. I have a block in the background that I'm measuring with this ruler. Here's the inches side. Here is the centimeters side. I'm going to use the metric side here. So I have this metric side of this ruler that I need to read to make my measurement and find my uncertainty. Well, how am I going to do that? The easiest way I found is to complete this small little table. Now, first of all, I look at my markings. I see here is a 9, here is a 10, here is 11, here is a 12, and I knew that my ruler is in centimeters. So my major scale here, ladies and gentlemen, is 1 centimeter. Now my minor scale are these little tiny dashes that are in between the major scale. And I look and I say, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 markings. I have 10 markings in between my major scales. So my major scale was 1 centimeter and 10 markings. So what I'm going to have is I'm going to take that 1 centimeter and I'm going to divide that by 10. Once I do that, I get my minor scale to be 0.1 centimeter. So up here now, I have a 0.1 centimeter for my minor scale. Gonna get that off of my board. Now, my measurement, okay? I'm gonna skip my measurement right now. I'm gonna skip my measurement until after I do my uncertainty, okay? Why am I doing that? Well, just simply, folks, that my uncertainty is going to be dealing with that minor scale. So I'm just going to show you this right now, okay? My minor scale, I just said was 0.1 centimeters. Now, I told you before, a couple of slides ago, that for an analog instrument, we take 1/2 of the smallest increment. Well, I divide that by 2. So I take 1/2 of that, I divide that by 2. So 0.1 divided by 2 is going to give me 0.05. So my uncertainty, ladies and gentlemen, is going to be plus or minus 0.05. So I have now calculated the uncertainty of that ruler. My final thing is I have to actually make the measurement. So as I am looking at this, I see that I have 10 here. Here is 10.5. I have 10.6. I do not have 10.7 yet. Okay? So I have 10.6. And now I have to have my estimation. And I'm going to estimate that as 10.66 centimeters. So that is my measurement, 10.66 centimeters. That last six here is my estimation. Now, how am I going to write this? Well, here's how I'm going to write that. 10.66 plus or minus 0.05 centimeters. So that says my uncertainty that I have with this reading. Okay? Now, what does that mean? What does that mean? Well, based on my ruler here, ladies and gentlemen, based on my uncertainty, if I were counting this in a lab, your numbers should be anywhere between 10.61, which is minus 0.05, or 10.71, which is plus 0.05. So, based on the uncertainty of the ruler, we should have values somewhere in between those two numbers, the 10.61 and the 10.71. Now, let's move on. Let's move on to a graduated cylinder. This, ladies and gentlemen, appears to me to be a 10 milliliter graduated cylinder. You have one of these in your lab drawers, so it'll probably be somewhat similar to this. I'm going to set up my boxes once again, and I look at my major scale on the table. My major scale 8, my major scale 9. So my major scale is 1 milliliter. Well, to look at my minor scale, I look and I say, okay, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once again, there are 10 readings in between the 8 and the 9. So I take 1 milliliter and I divide that by 10. This is also just like the previous one, only we're using milliliters, not centimeters. This is also going to give me a minor scale of 0.1 milliliters. So as I'm reading this scale, it's going to be somewhat similar to the ruler I just read there. Okay? Now, once again, my uncertainty. Uncertainty, if you remember, I take the minor scale, which was 0.1 milliliter, and I divide that by 2. So that's going to also give me a 0.05 for my uncertainty. So here we go, plus or minus 0.05. And the final thing is I have to come through and I have to make my measurement. So as I look right here, that meniscus, and remember I'm reading the bottom. I'm reading the bottom of the meniscus here. And I say, okay, I have 8. I know I have 8. I have 8.5. I have 8.6. But I do not have 8.7. So I have 8.6. And now I am going to read into my uncertainty. And as I read that, I'm saying that that is 8.68 milliliters. So that last 8, this guy right here is my uncertainty. That is my estimation. Now, once again, when I write this out, I'm going to write 8.68 plus or minus 0.05 milliliters. So the acceptable range for this reading right here, based on my instrument, is going to be anywhere between 8.63 milliliters and 8.73 milliliters. The plus or minus 0.05. All right, yet another example. We're getting a little bit different here, folks. A little bit different. Here is a 25 milliliter graduated cylinder. Okay? A 25 milliliter graduated cylinder. So, as I look at this, once again, I set up my table. I have major scale, I have minor scale, measurement, and uncertainty. Now, as I look, my major scale 20, my major scale 25. So, my major scale is 5 milliliters. Oh boy, this one's gonna be different. Now, as I look, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 markings. Okay, so 5 milliliters, 10 markings. Well, that looks to me like that's about a 0.5. That's 1/2. So each of my minor scale is 0.5 milliliters. Okay, 0.5 milliliters. Excuse me. Now, once again, I take my minor scale, I take my 0.5, I divide that by 2, and I know 0.5 divided by 2 is 0.25. Now, here comes the issue, because I cannot read this scale to the hundredths here. Okay? I can't read that scale to the hundredths. That's too precise. My precision on this scale is not so good. So I am going to round this to the 10th. Now, I would normally use what we call the even rule. Okay? I would normally use the even rule, but I'm not going to use the even rule in this case. Okay? The reason being, I am going to give you a little bit greater of a range to work with here. So I am going to be calling this uncertainty plus or minus. I'm going to round that up. Okay, even though that's not obeying the even rule, once again, I'm going to round that up. So my uncertainty here is going to be 0.3. Okay, so my uncertainty is 0.3. Now finally, I make my measurement. All right. I know that each one of these is a 0.5, each one of the markings. So I know I have 20, 20.0, 21. I know I have 21. I know I have 21.5. It's greater than 21.5, but it's not 22. It's pretty close to that 21.5 line, but not exactly. So I'm going to say 21.6 milliliters. So that 0.6 is my estimation. I'm saying that right here, as I'm looking at the bottom of that meniscus, that is not exactly touching that 0.5 line. It's a little bit higher. Okay? So, when I am dealing with my numerical range that I have, I'm going to have 21.6, and it's going to be plus or minus 0.3. 21.6 minus 0.3 is going to give me 21.3. 21.6 plus 0.3 is going to give me 21.9. So the acceptable range, if you were making this reading in the laboratory, would be anywhere between 21.3 and 21.9 milliliters based on the uncertainty of your instrument. Now, we've done a few examples of the analog. Let's go to a digital one here. Okay? Let's go to a digital one here. Now, I can see right here that I am making a reading of this particular cylinder to give me 34.7 grams. So what I need to look at with my measurement is how far out did the digital scale take it. When I see that that number is not in the tenths, it is in the hundredths. So my uncertainty of this scale is going to be in the 100ths. So that's how I get that plus or minus 0.01. 0.01. Let's go on to another one. Here's a little bit more of a precise scale. As I'm looking at this guy, I see tenths, I see hundredths, I see thousandths. So my uncertainty is going to carry me out to the 1,000th. So I have plus or minus 0.001. Okay? So I guess what's this telling me? What's this telling me? Well, I was doing ranges before, so you should have, for this particular one, let's add 0.0, let's add 0.01. So my top range should be somewhere 20.035, and my bottom range should be minus 0.01. So with this one, I guess I need to have labels. My range on the lab, if you were being graded on these numbers, should be anywhere from 20.033 grams to 20.035 grams. Now the last one we're going to look at here, our last slide, this guy right here, this is a vernier pH sensor. So later on in the school year, when we start talking about acids and bases, we're going to deal with our vernier equipment. So this will plug right into our computer, and as I look at my computer screen, it's going to spit out something like this to me. So my pH that I'm measuring right now is 8.20. So as I read that, that's the same thing. That's the same thing. So I'm going to look, and I'm going to get my plus or minus here. Okay? Here, then here. My accuracy is going to be not to the 10th, to the 100th for my uncertainty. So my uncertainty on this scale is going to be plus or minus 0.01. Ladies and gentlemen, this is Mr. Braun. We've been discussing the uncertainty in a single measurement. Chem students, let's investigate.